Okay, let's go ahead and draw this guy. Should look something. We're doing magnesium. All right, so first off, which direction are the electrons traveling? Towards the magnesium or away from the magnesium? How do you know that? Magnesium's higher up on, so it's more active. So magnesiums are more likely to give electrons to away than tin is. So electron flow this direction. This, what else do we want? Am I forgetting anything with this? I don't think so. Why did I pick potassium nitrate for the salt bridge? The potassium and the nitrate are soluble under all conditions. Nothing can make them a solid. So I don't have to worry about salts precipitating out. Okay. So what voltage is this cell going to generate? I should probably grab this and go up here. So we've got 10 and magnesium. So I've got that number there, and I've got this number here. One of these is backwards. So who's backwards? The magnesium is not gaining electrons, it is losing electrons. So this becomes 2.38, and then to that I'm going to add negative 0.14 volts. So we're going to end up with, okay, where'd it go? Oops, I don't want that. What was it? 1.24. What?
It would be 2.24.
Oh, my bad, 2.24, yeah. Can't do subtraction today. Is that a pretty good battery then? Sorry. Anything bad about that battery? Not really. Are metals expensive? These metals? I mean, it's just tin and magnesium, right? They're not that expensive. And tin density, not that much. Magnesium density, not that much. So this would turn out to be a pretty good battery. It wouldn't be that expensive. It generates a good voltage, and the metals aren't too expensive. I can't spell at all. Pharrell. Can I change it to Pharrell? Because that would be funny, maybe. Whatever. So we've got maybe something like this. Something like this. And then maybe something like this. and something like this. And so then I'll say that's a 1.5 volt battery, and that's a 1.5 volt battery, 1.5 volt battery, and a 1.5 volt battery. Okay, so what voltage is, or sorry, which one's which? Okay, so this one here is the series one. And how much voltage is that thing going to generate? 3 volts. So we're going to get 3 volts out of this guy. And this one over here, that's going to be 1.5 volts. And that 1.5 volts, I know it's half the voltage, but what's the good part about the parallel one? Lasts twice as long. Okay. Alrighty. What are some desirable qualities for batteries?
Light. They hold charge.
What else we got?
Cheap. Safe.
Anything else?
They use abundant sources.
That probably goes along with cheap, but I didn't think about that, but that's really good. Oh my God. I'm sorry, say that again.
For the most part, I think rechargeable is a desirable quality.
Oh, lots of charge cycles. Anything else?
Small.
Okay, let's say dense. Let me rephrase that. Let's go with this. A large charge density. So a small battery would be able to produce a great deal of voltage. And then one we're missing is a nice voltage, some voltage that's usable. When you purchase batteries, or if you're buying a cell phone and there are different battery options, what is it that you're looking at? What unit are they selling you on? Or if you're buying a one of those little battery pack things that's got a USB port on it and you can plug your phone into it to charge it portably, how are those things sold? Like what?
How many hours of charge you get off it?
Yeah, but there's a term for it. They don't usually use amp hours or watt hours. They'll talk about milliamps, and that's a good unit to use because the batteries are all at a fixed voltage, right? Because they're all producing voltage for a USB port. So you don't have to worry about the voltage part of it. They're all being pushed with the same amount of force. So now the larger the amperage, what's that telling you? What was amperage a measure of? Flow, the amount of flow. So if you have a larger amperage, that's saying there are more electrons available to do work. So a 50 milliamp battery would have twice as many electrons to actually do stuff than a 25 milliamp battery. All right, so how about this last one?
But somebody answered the converting the vehicles we have now to using this liquid.
Yeah, that's probably going to be
We're just phasing them out.
What do you do with your car that you have right now? It's tough, right? Everybody's invested in this infrastructure, and it's not like everybody can go out and buy a new car. So what do we do with the stuff that we have now? Phase it out, right? What kind can you give me an example of technologies that we phased out and we did a good job of it?
School computers, like 20 years ago.
Okay, so we don't have CRT television or screens anymore, right? We have these things. Nobody really cared that those got phased out. Anything else?
Cell phones, I guess, nobody has a Nokia brick anymore.
What?
It's useless.
Okay, so cell phones changed a lot. I saw the most hilarious 4.5-minute video. There was like two 13-year-old boys, and there was a box on the table, and somebody, like a grandfather or somebody, was talking, and he handed them a piece of paper with notes on it, and then he wrote on the screen what the note said, and all it said is, you have 4 minutes to make this phone call, and if you do, I'll give each of you $20. And they pull the little box off, and it's a rotary dial phone. They didn't do it. They could not figure it out. They were pushing buttons and like, well, how do you turn it on? And they're like unplugging and plugging stuff in. And they weren't screwing around. They were legitimately confused about the device. So, I mean, I can obviously use one because we had one. So is it a big deal that they're gone? No, nobody really cared. I mean, who has a landline phone anymore? Nobody in this room does. You guys have one? Why?
Because cell coverage where I live is really slow.
Okay, that's a great reason. Anybody else? That's something John Oliver was making fun of one day. You get your internet and your landline. Ooh, I get to bundle my landline. Like, who needs a landline? I use it to. What's the purpose of a landline? I lost my phone. I'm sure it's in a couch cushion, but I don't know which one, so I call it with my landline. Like, that's its only purpose. I was thinking more like music stuff or video stuff. Who's got a VHS player?
We did, but then we lost it.
You lost it? Somebody was like, we don't need this anymore.
It just kind of sucks. We had like a lot of VHSs. It's all the best old school packing videos are on VHS.
You can get them swapped over, but it turned out that they're more expensive than just buying them digital now.
And DVDs get scratched.
Yeah. And DVDs are disappearing, right? I mean, I lost like 150 of them when we had that fire, and I haven't replaced a single one of them because I'm just buying them digitally. Like, why would I want to carry that thing around with me? So we do this. We transition in and out of different technologies. It's been an ongoing process of us, and nobody's riding a horse to work anymore, to school anymore. So we can do this. It's just this has a little bit more of an impact financially, right? I mean, if you spent $40,000 on a truck for your farm 20 years ago, you're still trying to drive that truck. And it's not going to be easy for you to transition into like a Rivian that's $80,000 or the new Ford, which they haven't said how much that thing's going to cost, or the Tesla truck, which I'm sure is going to be expensive as well. So the number one thing is what's everybody going to do with their car? You can convert them. You may have seen people who have taken out the motors and put in electric motors in cars, filled them up with car batteries before lithium-ion batteries were a thing, and they're pretty cool. But there's a really, really tall guy who's like 6'8" around town, glasses, late 50s. Who?
With the mullet?
No, not him. This guy is an amazing dancer.
I know exactly what you're talking about.
Like, every woman at the bar, restaurant, will dance with him because he's ridiculously good. He owns a VW Bug that he converted into electric. Doesn't have any front seats, just has the back seat because he's like 6'9" or something like that. Okay, so we could convert our cars over. That could generate a lot of jobs, right? Also, making new cars that are electric could generate a lot of jobs. What else? What other problems are we going to have?
Well, the oil companies are going to fit.
Okay. Okay, so you might say, who cares, big oil? Why can you not just say that? Why does the transition have to be slow and not just like, we're off of it?
Because then what are we gonna do with all these like tanks that are buried underground under every gas station in America?
Okay, we'll slowly have to phase that stuff out. Anything else? How does big oil have a bunch of money? Like not everybody, but a lot of, especially older people, have 401ks and mutual funds tied to oil company revenues. And so what happens if the oil companies just turn zero profit? They're not going to have any retirement savings left because it was all tied up in these different things, which is why when you go into, if you talk to a financial planner or you decide to go buy into a mutual fund, some mutual funds are like, we're a green fund. We have nothing to do with any company who will produce greenhouse gases. We're not into any of that. Everything that you buy in our mutual fund is, it's all stuff that's green. It's all stuff that's going to reduce carbon emissions. So it's going to be a problem financially for a lot of people because they're tied up into it. Like not just grandma's 401k, but like something like PERS. Like those things are vested in oil companies because they made money. So you would invest in those. What else? Do we have enough lithium on the planet to do what Musk wants to do, which is power every single device with lithium? We right now, no, we haven't found it. I mean, it might be here, but we need to dig a lot of holes, which is also going to be another problem, right? We're going to need to do a lot more mining because we need to find more metals. In the same way that we dug a bunch of holes for fossil fuel, we're going to have to end up doing the same kind of thing for different minerals.
Could they go back into the same mines or like the same fracking spots and kind of be like, well, we overlooked this one, so we're looking for this? But
absolutely. That kind of stuff happens all the time. Like the technology changed and they closed that mine 50 years ago and they're like, this thing's got most of its in it still, but it cost too much then and now it's cheap to do that. So for sure, the old mines will definitely be looked at first.
What about what you're talking about, the installation of power lines? How like a lot of power is being produced, but not a lot of it's being shipped down. So like when everyone's plugging their car in,
it's going to be a problem. Yeah. I don't know if you guys remember the Enron issue from the late 90s. Doesn't matter. It's a company that was stealing and then, well, it doesn't matter. They caused energy problems based off of how they said they were providing energy, and people died. Like old people died because you weren't allowed to turn your air conditioner on, or if you did, the neighborhood would brown out, which means the voltage drops to a level that it can't run all the devices on it, and then a breaker drops, and then nobody's got any electricity. So that'll be an issue if we don't have a way to charge all of these devices on the current grid. It's going to be a problem. I mean, Obama was trying to it's a good word, modernize the electrical grid, and it never happened because it didn't have the right Congress. He was stuck on healthcare and never got out of that. So if we have a problem with the grid, is there something we could do to minimize that?
Well, right now, doesn't our grid run mostly off of fossil fuels anyway? Like how we're talking.
Half of it's coal. If we started pumping solar cells down on everybody's house, then no problem with that. You just charge locally, and then the grid isn't going to be an issue. But in making solar cells, you need certain types of minerals to be put into those cells, and so that means we got to dig more holes to come up with more. And it's mostly those metals that are on the second to last row down there, above the uranium roll in the actinide series on the far right, those rare earth metals. It's very small amounts, like parts per million and parts per billion of that, but when we're talking about billions of tiny little solar cells, that we need a significant amount of it.
This is more related to lithium, but I guess the possible issue would be finding a reasonable alternative. Like we were talking about.
A reasonable alternative to lithium? Yeah, so if we don't have enough of this, can we use, so we don't have enough lithium, we come up with another battery. Again, we talked about on Tuesday, Prius has been running off a totally different battery model, and it's been really good for them and really safe and has lots of charge cycles and discharges really quickly. But there's probably not enough of it on the planet either. So these are all things that we want to happen, but they're going to happen in a way that it takes a long time to go from, we figured out how to do this in a lab and then bring it to market. And we're going to have to do that a lot faster than we're typically used to. So these are all good things.